Hello everyone and welcome to this section. In this section, we're going to learn how to do image transformations. So we're going to learn how to do rotation, translation. We're going to learn how to do a lot of other processes too, such as region of interest masking. And we're going to end the section by actually doing kind of a fun project to detect lane lines in an image. All right. So let's get started with the first section. So first, we're going to cover how to perform image transformations. The first introduction for image transformation is if we have, for example, an image like this with the specific dimensions, what we could do is that we could perform scaling. So we can magnify the image, for instance. We can do linear transformation. So we can, for example, shift the image. We can, for instance, rotate it. We can do what we call it affine transformation and non-affine transformation, okay? So it's really simple. It just sounds, like a little bit scary, but it's very simple. So affine transformation mainly preserves parallel lines in simple form. So parallel lines for the original image and for the transformed image are preserved. So as you guys can see here, these two lines are parallel, and they are parallel here as well after transformation. These two lines are parallel. Yes, they are shifted, but again, they are still parallel. All right, and that's what we call it affine transformation. There's a different kind of transformation. It's what we call it non-affine transformation. It's what we call it projective transformation. That's when this actual sides move from being parallel to being, having kind of an angle in between. And that's what you guys can see here. Simply, these two lines were parallel in the original image, and they became, like having kind of an angle. They might intersect at some point in the transformed image. All right. So projective, what I'll call it non-affine transformation, they does not preserve parallel lines, and the length doesn't preserve the length or the angle. All right. That's just a quick overview of kind of transformation we're going to be doing. Again, it's very simple section, and then afterwards we're going to dig into a little bit more harder sections moving forward. Okay. All right. Let's get started. So first of all, we want to perform rotation. Okay, so again, we're going to use OpenCV. OpenCV is very easy to perform all these transformations. So first of all, we can use what we call it get rotation matrix 2D. Okay, that's kind of, we provide the center of where we're going to want to rotate the image. Want to provide the angle. How much do we need to rotate it? We're going to rotate it by, let's say, 45 degrees, by 90 degrees, and so on. And you're going to provide as well the scale, if you want to rotate and actually change the scale as well. Again, obviously, I don't like providing just commands without actually having practical applications. So right after this section, we're gonna actually dig deeper and see how can we apply that in the Jupyter notebook. So that would provide us, get rotation matrix, provide us what we call the M rotation, which is kind of the matrix that you can apply to your original image to get your rotated image, okay? So afterwards, after we get the M rotation, we apply what we call it warp affine, okay, which is again in OpenCV. So cv2.warp affine, and you provide the actual original image. You provide the M rotation, which is the matrix, and then you provide the dimensions of the image as well, and that will give us the rotated image, okay. And then we can plot our view or image show basically our rotated image and the original image as well to compare. I'm going to give you an idea of how can we perform that in the Jupyter notebook. But this is kind of the expected results. If we have this image and then you kind of, you're going to rotate it, let's say here 20 or 30 degrees, and then you can actually change the scale as well. So you guys can see that, the original image has been scaled down by a specific percentage. All right. Okay. And that's how to perform rotation. The second transformation we're going to be doing is what we call a translation. And that's how you actually translate the image or just move it, in a kind of a linear format. To do that, again, we're going to get a translation matrix. And then afterwards, we're going to apply the translation matrix using the warp affine again to get us the translated image. Very simple. We have our image, and what we're going to do is we're going to shift it, let's say, in the X direction and shift it in the Y direction. Okay. So in order to do that, we create that matrix. So we'll call it translational matrix. You provide here 1, 0, 0, and 1. That's pretty much fixed. And then here you put the number of pixels that you wanted to translate in the X direction, Tx, and in the Y direction, Ty. You get the translation matrix T, you get the T, and then you put it here along with the original image, along with the dimensions that you want, and that will give us the translated image, okay? And that's pretty much what you expect. You will see that you basically shifted the image in the X and Y directions, and that's what you guys get here. The image is pretty much the same. We haven't done anything to the image. You obviously can mix if you want to translate it and if you want to rotate it. There's like unlimited stuff that you could do. All right. The third transformation is what we call resizing, which can be used to resize the image. Again, we can use resize from OpenCV. You give it the original image, you give it the scale. Do you want to make it bigger? We're going to make it smaller. In which direction as well, FX and FY. And then you do kind of the method of interpolation. How do you want to interpolate between the pixels? Do you want to interpolate in a linear format, in a cubic format, and so on? In general, we use kind of the like CV dot inter area for shrinking, and we generally use cubic for zooming. And then you can use as well linear for pretty much most purposes. All right. And that's pretty much all what I have for this section. I hope you guys enjoyed it, and let's apply all what we learned in an actual Jupyter notebook. See you in the next section.